Network troubleshooting. We're going to look at that physical network, troubleshooting it and the tools that we need. The good old multimeter to check for connectivity, check for impedance mismatch. Good old nut drivers, cable strippers to take off the end of the wire, snips to cut them, punch down tool to put that network cable into the 110 block. Back in the server room, crimpers, and here's crimpers. Butt set. Butt set is used by a telephone lineman to check for communications, to make sure that that phone line is actually working. A time domain reflectometer, or TDR, is used to look for a break in a cable. Puts a signal on the wire, it bounces when it hits a break, comes back, it can let you know exactly how far down that cable that break occurs. Now, TDR is nice with copper, but what if you've got fiber? Then you use that OTDR, the optical time domain reflectometer, and it does the same thing. A certifier certifies a cable is making a certain grade, Cat 5, Cat 5e, Cat 6, Cat 6a, whether or not it actually meets those requirements. Temperature monitor, computers like about 68 to 74 degrees Fahrenheit, 18 to 24 degrees Celsius. They also tend to like about the same level of humidity we do, about 40 to 60, 45 to 65% non-condensing. You might have a voltage event recorder looking for power problems in equipment, not so likely to be used by a technician. Toner probe, looking for where a network jack, it's out there on the wall somewhere. Where is it on your patch panel? You run the toner probe over. When it makes a loud screeching noise, you found the right one. Loopback plugs to test to see if your network jack is functioning, used in conjunction with diagnostic software. So troubleshooting those wired connections. You want to look for electrical interference. Don't run network cables over electrical cables. They will interfere with each other. They'll cause interference. Your network may not be stable. Network noise will come about. Now, crosstalk is where data jumps from one cable to another. You have two cables next to each other. Potentially, data can jump from one to the other. Now, the cables are twisted inside. That helps minimize crosstalk. But if you stretch those cables, they tend to untwist and crosstalk becomes more common. Also, at the very end, where you put on that RJ45 jack, this is a nice one. The jacket is inside. It's only about 1 centimeter from the end of the jacket to the end of the wires. That's about perfect. But I've seen bare wires come out to here. It's all untwisted. You're going to have at the very end, jumping from one cable to another, right at the patch panel or similar. And that's called near-end crosstalk. Attenuation, loss of signal strength over distance. You get a longer cable, it tends to break down. Most twisted pair cables are only rated at 100 meters. Collisions on a network. Collisions is when two people send data at the same time and it collides with each other. The data is effectively destroyed. That's not good. Switches have pretty much stopped collisions. A fully switched network, everyone's on their own switch port. No one's data should touch anyone else's data. Takes care of the problem. Open impedance mismatch. Now, you're looking at something like coax cable. If you're using a BNC connector, for some reason your network is wired coax, don't do this. Twisted pair is beautiful. Fiber's nice. But on the end, it should be 50 ohms on both sides. Well, someone may have put 75 on one side, 50 on the other. That's going to create a problem. Or they forgot to terminate, which will create a problem. There are cable testers. You see one there, here's one here. Use this for testing standard twisted pair cables. RJ45, RJ45. If I want to test a regular phone cable, RJ11, other side, RJ11. Now I just take this, plug it in, plug this into the other side, and usually these will be far apart. Turn it on, and what did I do? Okay, it counts down, goes down saying they're all good. Let me put it in slow mode. So it's checking each one. You'll notice they're the same because this is a good cable. You can check functionality of that cable, make sure it works, not miswired. Physical cable test, locate miswired cables. Cable tester's good at that. Open cables, shorts. Locate missing cables, a toner. Locate unsupported cables. A certifier lets you know if it meets the right qualifications. Maybe you have a requirement for Cat 5e cable and someone had some old Cat 5, or you want Cat 6 because you're looking to upgrade to gigabit and there's old Cat 5 cabling there. You want to know about it. Test hub connections, test the PC connection, test install cables. A lot of this is done with that certified test patch cables certifier or cable tester to just make sure it's a good cable. Locate inactive cables, that toner probe, see where it's connected. Network function test. Verify a PC or hub is on. Specify whether that device is a network PC or it's a hub. Display the maximum network connection speed to the device. Verify PC to hub speed, data transmission and port speed, or duplex mismatch. Remember, you should know the specifics of the switch or hub you're connecting to, and you want to set your PC to transmit matching it. Verify hub to hub, data transmission, switch to switch. Remember, same device, crossover cable, different devices, straight through. So, straight through a crossover cable. If it's the same type of device, crossover cable. Find speed bottlenecks on the LAN. That's probably going to be with a protocol analyzer. It's going to be with a sniffer on the computer. It's going to be with diagnostic tools, performance monitoring. And monitor a LAN link between two devices. That would be a protocol analyzer or sniffer. And there's a protocol analyzer. Pretty nice looking one. You can identify problems with cables, the jacks, network cards, hubs, low-level OSI hardware, layer 1, layer 2, and sometimes as high up as TCP/IP. That's a pretty nice one. You get to look at all the different data that flows through.